Okay, so today we're going deep, really deep, into the world of power systems and transformer tech.
Yeah, should be a fun one.
I think so. It looks like you've put together a pretty fascinating set of articles and reports covering, well, honestly, a lot.
Oh yeah, it runs the gamut pretty much from like the big picture political stuff that's shaping how we electrify the planet to the super technical nitty-gritty of how to actually keep these giant transformers humming and even how digital marketing is making waves in the power sector.
Digital marketing, now, that's not something you'd normally associate with, well, transformers.
Right. I mean, it's not exactly the flashiest industry, but it's crucial, and they're starting to get savvy about how to reach the right people.
So our mission, should we choose to accept it, is to distill all this down, make the connections, and give our listeners a clear picture of what's really going on in this world.
Yeah, absolutely. And our main source, it's actually a treasure trove of insights, is the latest issue of Transformer Technology magazine.
Ah, so we're going straight to the experts then.
Yep, straight to the source. And we've got a lot to cover. We're talking CEO perspectives on the future, like what's on the horizon for 2025 and beyond. Then there's some deep dives into things like gas chromatography and how it's making dissolved gas analysis way more accurate. Plus, there's a whole section on figuring out how to really assess the health of these transformer assets, not just relying on guesswork.
Yeah, I was actually looking at that one earlier. Seems like they're moving towards a much more holistic approach.
Totally. Then there's a really interesting article recognizing the increasing role of women in leadership positions, which is great to see, and a deep dive into the next generation of insulation they're using for those massive data center transformers.
Those things are power-hungry beasts. I bet the insulation has to be top-notch.
No kidding. And speaking of power, we've also got a whole section on the global energy transition, what's actually happening, where the money's going, what the roadblocks are, that sort of thing.
That's a huge topic right now, and it's definitely one where, emotions can run high.
Oh, yeah, for sure. But we'll stick to the facts and see what the experts are saying. Then we've got some really practical stuff on DGA monitoring alarm strategies, how to avoid getting bombarded with nuisance alarms and actually focus on the ones that matter. And then, well, there's that digital marketing piece we mentioned.
The one that caught me off guard.
Right. And to round things off, we've got an exploration of the future of industrial maintenance, how generative AI is going to change the game, and then we'll wrap it up with a panel discussion on, well, pretty much everything we've covered: monitoring, diagnostics, maintenance, reliability, the whole 9 yards.
Okay, sounds like we have our work cut out for us, so let's jump right in.
This is good of me.
All right, so this whole thing about the politics of electrification, it really jumps out from all these articles that the power industry, it's not just making small tweaks, they're in the middle of a pretty fundamental transformation.
Yeah, I mean, think about it. We've got this massive global push towards electrification. Like everything's going electric, from cars to heating systems, and that's putting a huge EE strain on the existing power grids.
It's not just the sheer number of things plugging in either. It's also the power they demand, right? Like those data centers running AI, they suck up electricity like nobody's business.
Oh, yeah. They're energy hogs, no doubt. And electric vehicles, too. They're putting a big dent in the energy equation. So it's not just a case of adding a few more power plants. We need a complete rethink of how we generate, transmit, and distribute power.
And this transition to renewables, well, it's happening, but it's not happening overnight, that's for sure. One of the articles pointed out that while we see all these big investments in solar and wind, fossil fuels are still very much a part of the global energy mix.
Yeah, that's one of the more complex aspects of this whole transition, right? Like you got countries like India and China, they're still building coal-fired power plants, and their argument is, well, the developed world built their economies on fossil fuels, so why should they have to do things differently?
It's a tough one, and one of the articles even mentioned that this whole green energy push is actually facing some political headwinds.
Yeah, there was a point made about how a recent change in administration led to a shift away from a really strong green energy focus towards, well, more support for traditional oil and gas.
Makes you wonder, right? Like, how much can political shifts really impact the momentum towards a cleaner energy future?
It's definitely a factor, but the overall sense I got from the articles is that a complete reversal on this is probably unlikely at this point.
More like a course correction, maybe.
Yeah, maybe. But the reality is oil and gas are probably going to be part of the mix for a while yet. It's more about finding a balance, right? Pragmatic approach rather than getting stuck in ideological debates.
And one thing that seems to be a roadblock on both sides of the energy debate it's actually permitting.
Oh, yeah, that's a big one. Getting the green light for any new project, whether it's renewable or traditional, it's a huge hurdle, and it's slowing things down across the board.
So streamlining the whole process, making it more efficient, that seems like a crucial step, no matter which way you lean on the energy spectrum.
Couldn't agree more. Okay, so moving on, let's get into the more technical side of things, specifically dissolved gas analysis, or DGA. This seems like the absolute cornerstone of keeping our power grids reliable.
It's essentially like taking the pulse of these giant transformers, right? Making sure
Yeah.
they're healthy and not about to blow a fuse.
Exactly. It's all about detecting faults, problems that are developing within the insulating oil inside the transformers. So think of it like a blood test for these critical pieces of equipment. The accuracy of those DGA measurements is paramount because, well, it directly impacts everything from when you need to investigate a potential issue to when you have to, pull a plug and replace the entire unit.
No pressure then, right?
Right. And there's a lot of discussion these days about whether traditional manual sampling for DGA or using continuous online monitoring gives you more reliable results.
I mean, intuitively, you'd think having real-time monitoring would be more accurate, wouldn't you?
Yeah, and the information in these articles seems to back that up. Manual sampling, while it's still pretty widely used, it just inherently has more room for error. Like you could get contamination when you're drawing the sample. There can be inconsistencies in how it's handled. And then there's the time delay. You take the sample, then you ship it to a lab. And by the time you get the results, well, who knows how much the situation might have changed.
Whereas online DGA monitoring, it's happening right there, right on the transformer itself.
Exactly. And you eliminate a lot of those human-related errors that can creep in. And what's really interesting is that online systems, especially the ones using gas chromatography or GC technology, they're often self-calibrating.
Self-calibrating, so they're constantly checking and adjusting their own accuracy.
Pretty much, yeah. The information here suggests they typically do this like twice a week, so you're not relying on a one-time calibration that might drift over time.
There was also something about consumables, wasn't there? I mean, I guess I always assumed that online monitoring systems wouldn't need as many consumables as, a traditional lab setup.
Yeah, but it seems like that's not really the whole story. Apparently, almost all online DGA systems require some kind of consumables to function properly. It's just that some manufacturers might not be as upfront about it.
So the real differentiator is more about transparency and whether the system has that regular, verifiable calibration that GC technology is known for.
Exactly. I mean, the data even show that the accuracy of a typical lab analysis can drop off quite a bit when you're dealing with really low gas concentrations. And those are often the early warning signs you're looking for.
So in the battle for DGA accuracy, online monitoring with GC, it's got the edge, it seems.
Yeah, I think that's a pretty fair assessment. And as our grids get more complex and we demand more reliability, investing in these more sophisticated solutions, it just makes sense.
All right, so we've talked about keeping those transformers healthy, but how do you actually assess their overall condition? How do you decide which ones are in tip-top shape and which ones need some TLC?
Well, that's where these transformer asset health indices come into play. Think of them as like a credit score for your transformers. It's how asset managers rank their units and figure out which ones need attention first, whether it's routine maintenance or something more serious.
Makes sense, but it seems like there's no real standard way of doing this, at least not across the entire industry.
Yeah, that's one of the challenges highlighted in these articles. A lot of the traditional approaches focus mainly on oil analysis, looking at the DGA results and the overall quality of the oil. But that only gives you part of the picture.
Because a transformer can have problems in other areas that aren't reflected in the oil analysis, right?
Exactly. Like you can have issues with the bushings, the cooling system, things like that. And if you're just looking at the oil, you might miss those completely.
So you need a more holistic view, right? Something that takes into account all the different subsystems.
Absolutely. And one of the articles proposes a method called the condition index.
Mm-hmm.
And it's really interesting because it considers the main tank, the LTC, the bushings, the cooling system. It brings it all together.
Sounds pretty comprehensive. How does it actually work?
So they've got this thing called a condition group, which is basically the worst condition found in any of those key components. And it's rated from 1 to 5, 1 being good, 5 being, let's just say you need to call an ambulance.
So the higher the number, the bigger the problem.
Yep. Then they have the overall health index, which is a decimal value between 0 and 0.99, where 0 is perfect health and 0.99 is not so good.
Okay, and this takes into account things like inspection reports, electrical tests, even data from online monitoring, right?
Exactly. So you get a really well-rounded view. And what's cool is they combine those two numbers, the condition group and the overall health index, into a single metric.
So you can quickly see which transformers are in trouble and which ones are doing okay.
And even if two transformers have the same worst-case condition, their overall health index can tell you which one is more urgent.
That's pretty smart. And they even use this to estimate the probability of failure, right?
Yeah, which is super important for risk assessment, trying to avoid those situations where you suddenly have a multi-million-dollar outage because a transformer went kaput.
Speaking of power-hungry beasts, let's talk about data centers. Those things are growing like crazy, and their energy demands are just, well, monstrous.
Yeah, and these articles really emphasize how crucial it is to optimize the insulation inside those data center transformers because the stresses they're under are immense, way higher than your typical power transformer.
And we're talking about heat, electrical stress, mechanical stress, the whole works, right?
The whole works. Yeah. And it all comes down to that solid insulation, especially the paper insulation they use in these larger units, because it impacts everything from the size and weight of the transformer to its efficiency and, of course, its reliability.
They even talk about specific types of insulation paper, like there's this diamond pattern enhanced paper, or DPE, that seems to be getting a lot of attention.
Yeah, DPE paper, it's specifically designed for these liquid immersed transformers, and it's got some pretty impressive benefits, like its thermal endurance is way higher, meaning it can handle higher temperatures for longer without breaking down. It also dries and impregnates faster during manufacturing, so it's more efficient to produce. And it's got better dielectric properties, which, well, basically means a better insulator.
So what does all that translate to for the data center operators?
Well, they can run their transformers hotter without worrying about them failing. They can handle bigger overloads, or they can get the same performance in a smaller, lighter, and potentially cheaper unit. So, it's a win-win all around.
It sounds like this optimized insulation is a pretty big deal for keeping the data flowing.
It is, especially as these data centers just keep growing and growing.
All right, let's zoom out a bit and look at the global energy picture. There's an article here titled, "A New Beginning for Our Global Energy System," and it actually paints a somewhat optimistic outlook, suggesting that 2024 might have been the year we finally peaked in global emissions.
Yeah, there's a sense that while we're not out of the woods yet, the trend is finally starting to shift in the right direction. The DNV report they cite suggests that CO2 emissions from burning fossil fuels are on a slow but steady decline, and they predict a pretty significant reduction in energy-related emissions by the middle of the century.
So a reason for cautious optimism, but not a time to get complacent.
Exactly. And the report also acknowledges that even with these reductions, we're still likely to see a global temperature rise of about 2.2 degrees Celsius by the end of the century, which is, well, not great.
It's still above that 2-degree target that everyone's been aiming for, but at least it's moving in the right direction. And the report also talks about this massive surge in global electricity demand that's coming.
Yeah, we're talking about a potential doubling of demand within the next 25 years, which means we need to drastically expand our power grid infrastructure, like basically double the length and capacity of our transmission and distribution networks.
That's a huge GE undertaking, but the good news is that they predict electricity generation will be 90% decarbonized by 2050, with solar and wind providing the lion's share of that clean power.
Yeah, and we've seen some pretty impressive growth in solar PV installations recently. I mean, in 2024 alone, installations jumped by 80%, which is just mind-blowing.
And electric vehicles are also taking off, right? They're projected to be 25% of all new passenger vehicle sales by the end of 2025 and 50% by 2031.
Yeah, so the shift is definitely happening, but the article does point out some potential roadblocks, things that could slow us down.
Like political and budgetary hurdles, right? Those can definitely derail even the best laid plans.
Absolutely, and there's always the risk that geopolitical priorities or concerns about energy costs might overshadow the climate goals, which could lead to delays in implementing policies that support renewables.
But the author seems to think that the inherent efficiency of electrification itself could actually become a driver for more supportive policies.
Yeah, the idea is that as more of the economy electrifies and the benefits become more obvious, less pollution, lower operating costs, that sort of thing, policymakers will have more leverage to push for renewables.
So it's not just about the technology, it's also about making a strong economic case.
Exactly, and the article also emphasizes how important it is for consumers and businesses to make their voices heard. to really push for change and influence those investment decisions and policies.
So we're all part of this transition, not just the big players.
100%. And it's interesting, even with all this focus on renewables, the report still predicts that fossil fuels will be providing about 12% of the world's electricity in 2050.
So a big drop from where we are now, but not a complete elimination.
Yeah, it suggests we're probably not going to hit true net zero emissions by then, but hey, progress is progress.
All right, let's get some insights from the people who were actually leading this charge, the folks on the front lines. We've got this CEO forum in the magazine, and it looks like they brought together some heavy hitters to talk about the future of the power sector.
Yeah, they had John Bucciarelli from SD Myers, Angelo Rizzo from Systems with Intelligence, and Martin Robinson from Iris. So, pretty impressive lineup.
And it sounds like one of the key takeaways was that the power industry is going through more tech-driven change right now than ever before.
Oh, yeah. They were all pretty clear about that. And Angelo specifically talked about how utilities are starting to adopt technologies from other industries, which is pretty interesting.
Yeah, I saw that they're borrowing ideas from aerospace and manufacturing and even the military, all in the name of making the grid more reliable and, smarter.
It makes sense. I mean, there are a lot of smart people working in those fields, so why not learn from them? And John made a really good point about how NFPA 70B, that standard for electrical maintenance, it's becoming a lot more important now.
It used to be just a recommendation, right? Now it's the law of the land.
Pretty much. And he also highlighted the challenges that industrial customers are facing, things like these long lead times for equipment, concerns about reliability, and the fact that their energy consumption is just going through the roof. He even predicted it could double by 2035.
That's a scary thought.
No kidding. And Martin had some pretty strong opinions. He basically said the industry hasn't been investing enough in training and education, especially when it comes to understanding the risks associated with electrical systems.
He even used that phrase, silver tsunami, right, to describe all the experienced engineers who are retiring and taking their knowledge with them.
Yeah, he's pretty worried about that knowledge gap. And he also sees safety becoming a bigger and bigger concern as equipment ages and the risk of failures goes up. I mean, he painted a pretty vivid picture of what can happen when things go wrong, and it wasn't pretty.
Multi-million-dollar losses, environmental damage, the whole 9 yards.
Exactly. So they all agreed that we need to get a lot more proactive about safety and maintenance, and that means embracing new technologies like IoT, machine learning, and AI.
John even shared a story about a client who lost $52 million because of a single transformer failure.
That'll get your attention, right?
Yeah.
It really drives home the point that preventative maintenance is a lot cheaper than dealing with a major outage.
Okay, let's talk about DGA monitoring alarm strategies. Setting up these systems seems like a delicate balancing act because you want to be alerted to potential problems, but you also don't want to be drowning in false alarms.
It's a tough one because if you're constantly getting bombarded with nuisance alarms, you tend to tune them out, and then you might miss the one that really matters.
Alarm fatigue, right?
Exactly. And the information here breaks down alarm management into 3 key parts. First, you've got the initial configuration, actually setting those alarm levels. Then there's the response process. What do you do when an alarm goes off? And finally, there's the whole process of establishing and adjusting those settings over time.
And when it comes to setting the initial levels, it seems like a one-size-fits-all approach just doesn't cut it.
Nope. You have to consider the specific transformer, its age, how it's being used, its history, all that stuff, because what might be a normal gas level for one transformer could be a huge red flag for another.
And they really emphasized the importance of having a clear, documented process for making changes to those settings.
Oh, yeah, you need a paper trail, for sure. Otherwise, you're just guessing. And then when an alarm does go off, well, you need to have a plan.
Like a step-by-step guide, right? Who does what tests need to be run, all that.
Exactly. And it's not just about reacting to every alarm in the same way. You need to prioritize. So they make this distinction between operational alarms, which are like, hey, this is bad, shut it down now, and asset health alarms, which are more like, okay, something's trending in the wrong direction. Let's keep an eye on this.
Makes sense. And they also talk about the challenges of multi-gas DGA monitoring.
Yeah, it's not just about setting an alarm for each gas. It's about understanding how those gases interact and what the overall picture is telling you.
And those service alarms, those are tricky too, because it could just mean there's a problem with the monitoring system itself, not the transformer.
Yeah, got to be able to tell the difference. And one of the points they make is that having separate caution and alarm thresholds for each gas is really helpful.
So it's like a tiered system, right? A caution level might trigger some basic checks, while a full-blown alarm means it's time to take action.
Exactly. And the actions should be clearly defined. If you get a moisture alarm, maybe you just do some extra trending analysis. But if you get an acetylene alarm, that could mean de-energizing the transformer.
No messing around with acetylene. That's a pretty clear sign of trouble.
And they also talk about using rate of change thresholds, which is a pretty smart idea.
So it's not just about the absolute level of a gas, it's also about how quickly it's increasing.
Exactly, because a sudden spike could be a much better indicator of a problem than just slowly creeping up to a threshold.
And then there's the whole issue of nuisance alarms. Those are the bane of any monitoring system.
Oh, yeah, carbon monoxide, carbon dioxide, TDCG, those are the usual suspects. And the problem is that they can make you numb to alarms in general.
So the key is to be really smart about how you set those thresholds and to be willing to adjust them over time.
Yep, and they even mentioned that using machine learning to manage these alarms is a promising area of research. But for now, the best approach is to collect some baseline data, see how the transformer normally behaves, and then set your alarms based on that.
Okay, let's end on a positive note. We've got some good news from the manufacturing side. Apparently, the LTC group is making a big investment in expanding their production capacity.
Yeah, they're building a brand new facility in Italy, their 7th one, and it's going to add a whopping 10,000 tons to their annual production capacity.
10,000 tons. That's a lot of magnetic cores.
It is, and it's a clear sign that demand is booming. And they're also building another facility specifically for robotic production of core armatures.
So they're not just expanding, they're also getting more high-tech.
Yep, and they're increasing production across their entire product line. Shunt reactors, distribution transformers, power transformers, even stuff for the railway sector and smart grids.
Seems like they're really positioning themselves to be a leader in this whole energy transition.
Exactly, and they're big on sustainability too. Investing in Industry 4.0 and 5.0 technologies, using innovative materials, all that good stuff.
So it's not just about making more, it's about making it better.
Absolutely. Okay, so here's a topic that might surprise some people. Digital marketing in the power sector.
I mean, it's not exactly the sexiest industry, right? You don't see a lot of flashy ads for transformers.
True, but these articles make a really compelling case for why digital marketing is so crucial, even when a lot of the sales happen through those formal tender processes.
Because it's all about building relationships and establishing credibility, right?
Exactly. And educating potential customers, getting them familiar with your company and your solutions before they even start thinking about putting out a tender.
So it's about planting those seeds early on.
Yep, and building that brand awareness so that when they are ready to buy, well, your name is already at the top of your list.
And they even say that smaller, newer companies can compete with the big boys by having a strong online presence.
Totally. It's all about creating valuable content, like white papers, webinars, podcasts, things that showcase your expertise and give people a reason to trust you.
And case studies are huge, right? Show them how you've solved problems for other companies, just like theirs.
Absolutely. And they really stress that if you want to grow, especially if you're thinking about expanding internationally, a solid online marketing plan is no longer optional. It's a necessity.
So even in this traditional relationship-driven industry, digital marketing is becoming a game changer.
It is, and it's not just about dry technical specs. They talk about the importance of creativity and storytelling, making your brand stand out.
Okay, final topic. Generative AI and the future of industrial maintenance. This sounds like something straight out of science fiction.
It kind of is, but it's also becoming reality. They're talking about using AI to empower what they call citizen maintenance workers, essentially giving frontline employees the tools to diagnose and even fix problems themselves.
So it's like having an expert in your pocket, guiding you through the process.
Pretty much. And this is especially important because of that whole silver tsunami thing. All those experienced technicians retiring and taking their knowledge with them.
It's a huge challenge for a lot of industries, but especially for power utilities, where the stakes are so high.
No kidding. And these AI systems, they can capture all that expert knowledge, all those years of experience, and then make it available to anyone who needs it.
So it's not just about fixing things. It's also about preserving and transferring knowledge.
Exactly. And these AI-powered systems can do some pretty amazing things, like they can continuously monitor equipment health, analyze sensor data, provide diagnostics, even suggest corrective actions.
They even learn and get better over time.
Yep. The more they're used, the smarter they get. And the article lays out 6 key benefits of using AI for maintenance. Things like faster troubleshooting, more efficient use of your workforce, continuous learning, standardized best practices, and so on.
Sounds like a pretty compelling case. And they even give an example of how this could work in practice. Assembly line worker using AI to figure out what's wrong with a noisy motor.
Yeah, it really brings it to life. And it highlights how AI can help companies shift from a reactive maintenance approach to a much more proactive one.
Okay, we've got one more panel discussion to cover, and this one focuses on monitoring, diagnostics, maintenance, and reliability. So, everything we've been talking about.
The whole shebang. And they've got another great lineup of experts, including Brad Bonus, Emilio Morales, Bob Razor, and Mark Tostred.
And it sounds like they all agree that the world of M&D is changing rapidly thanks to all these new sensor technologies, data analytics, and AI.
Yeah, the challenge now isn't just collecting data. It's making sense of it, interpreting it, and then actually using it to make informed decisions.
So data everywhere, but how do you actually extract meaningful insights from it?
That's the million-dollar question. And they also talked about the growing importance of cybersecurity, making sure all these interconnected systems are protected.
Because a cyber attack on the power grid, that's a pretty scary thought.
No kidding. And they also talked about how utilities are under a lot of pressure to squeeze more life out of their existing assets, because getting new transformers can take forever.
Yeah, lead times are crazy these days.
So they're investing heavily in monitoring and automation, trying to do more with less. And they're also seeing a big increase in the number of data scientists and condition-based maintenance teams within utilities.
So the industry is definitely adapting, becoming more data-driven.
Definitely. But they also acknowledge that there are still challenges, like the aging workforce, aging infrastructure, and sometimes just a lack of budget for these more advanced monitoring systems.
And they stress the importance of integrating data from different sources, not just relying on a single sensor or technology.
Because the real insights come from seeing the whole picture, and they're moving towards more predictive monitoring, trying to anticipate problems before they happen.
And making all that data accessible through dashboards so everyone can see what's going on.
Yep, transparency is key. And they talked about this progression from monitoring to data to dashboards to actually using that data to make informed decisions.
So it's not just about collecting data for the sake of it. It's about turning that data into action.
Exactly. And they really emphasized how important it is to track trends over time, to see how things are changing. And that's how you start to develop real knowledge and expertise.
And they talked about how utilities are good at piloting new programs, but they need to scale those up to really see the benefits.
And that takes a long-term vision, corporate buy-in and a willingness to invest in the future.
And they also discussed the importance of understanding correlations between different parameters, how one thing might be impacting another.
Because sometimes the problem isn't obvious, it's hidden in those subtle connections.
They also talked about how budgets can be a major constraint, but the real cost savings come from preventing those catastrophic failures.
Right, an ounce of prevention is worth a pound of cure. And they even recommended having spare transformers on hand, just in case.
Which can be tough given those long lead times we talked about.
Yeah, but it's better to be prepared. And they also said that even simple things like infrared scanning can be a really valuable starting point.
So you don't have to jump in with the most advanced technology right away. You can start small and build from there.
And they made a really good point about how you can't just justify these monitoring programs based on maintenance savings alone.
Because the real value is in preventing those big outages, the environmental damage, the impact on customers, all that.
Exactly. And while it's easier to integrate monitoring into new equipment, they acknowledge that dealing with the existing fleet, well, that's a whole other challenge.
So we've covered a lot of ground here. Everything from the big picture of electrification to the nitty-gritty of transformer maintenance. It's been a pretty wild ride.
It has. And if I had to pick a few key takeaways, I'd say remember that alarm fatigue is a real thing. So be smart about how you manage your alarms.
And that shift from reactive maintenance to proactive maintenance, that's crucial.
Yeah, ditch maintenance, Mike, and embrace steady Eddie.
Yeah.
Don't underestimate the power of digital marketing, even in this seemingly old school industry.
So here's a final thought for our listeners. With all these experienced engineers retiring and AI coming onto the scene, how do you think the roles and skills needed in the power industry are going to change in the next decade? What do you need to do to stay ahead of the curve? It's a question worth pondering.
For sure. It's going to be an interesting ride. That's for sure.
Thanks for joining me on this deep dive. It's been enlightening, to say the least.
My pleasure. Always happy to talk Transformers.
Until next time, stay curious and keep those lights on.